Codegeist LLM is an early-stage project. Can a local model explain a computer without controlling it? The model may advise, Codegeist OS would decide. The first public adapter is 34.9 megabytes. Its A10G training run took 133 seconds and cost about 5 cents. The 1.7 billion parameter model and adapter run on an NVIDIA A2000 GPU. The model advises, the operating system decides. Codegeist LLM has one intended role: help a person understand a computer within operating system boundaries, not act as a general chatbot. Local means that inference runs on the user's computer, not through a public-hosted AI service. Inference means running a model to produce an answer or proposal. It is not building or training the model. The design allows 5 outcomes. Request one read-only diagnostic, return a diagnosis, abstain when evidence is insufficient, request escalation, or return a non-executable plan for human review. It is not a root shell, administrator, policy engine, public AI service, or general chatbot. Every output remains an untrusted proposal. These roles, schemas, and Codegeist OS integration are not implemented, and the current adapter does not perform them. 3 related names describe 3 different projects. Codegeist is the current open-source coding agent project. It is the broader project people can inspect and develop today. Codegeist LLM is separate. Public source and a first adapter exist today. A specialized model and unprivileged native worker are design targets, not shipped components. Codegeist OS is the future environment around that worker. It would collect and redact data, isolate processes, enforce permissions, validate proposals, audit decisions, and control every actual action. The model project owns model, worker, provenance, evaluation, and release evidence. Codegeist OS would own security authority. No usable OS release, AI user, policy engine, privilege broker, or integration exists today. A model can sound confident and still be wrong, incomplete, or unsafe. Its output cannot become permission. Personal files, credentials, devices, networks, other processes, package management, and administrator privileges must remain outside the model's authority. A prompt, document, log, or web page must not move that boundary. The model is not an operating system identity. It cannot grant itself a device, reveal a keyring, or turn one approval into a reusable shell or token. The target is least privilege. Deny access by default, then expose one named operation with a narrow target, limited data, and clear lifetime. Sensitive requests need specific human approval and must remain safe to deny or revoke. Policy, audit, and recovery stay independent. This unimplemented target is no OS guarantee or proof of AI safety. In the intended read-only flow, a person asks Codegeist OS for help. The OS chooses a permitted diagnostic, collects a deterministic observation, and removes data the model does not need. Redaction. An unprivileged Codegeist LLM worker receives one bounded context: instructions, observations, history, and output space for one turn. It has no shell, public service, or direct route to system data. The model returns a machine-readable proposal, a read-only request, diagnosis, abstention, escalation request, or non-executable plan. It remains untrusted. Codegeist OS checks the proposal schema or expected shape, then its fields, evidence references, meaning, policy, and permissions. Constrained generation can fit syntax to a schema. It cannot prove correctness, evidence, or authorization. Then a person sees a validated diagnosis or plan. The model neither collects, authorizes, nor executes. This auditable flow is not implemented. Consider an explanatory example, not a product demonstration. A person asks why storage is filling. The model cannot inspect the computer. It can only propose one typed, read-only request for disk use and log size observations. The operating system decides whether the diagnostic is allowed. A deterministic tool returns generic facts with observation identifiers. No file changes, and the model receives only observations allowed by policy. The model might propose that growing logs are the cause and return a non-executable review plan. The diagnosis cites observation ID, but remains only a proposal. Codegeist OS checks fields, evidence, policy, and outcome. It can accept a bounded diagnosis while rejecting an invented action, unknown field, or unsupported conclusion. With insufficient evidence, abstain and name what is missing. The person sees only a validated diagnosis, abstention, or non-executable plan. Nothing runs. The model proposes, the OS decides. This exchange is not implemented. The target starts with an unprivileged C++ worker supervised by Codegeist OS. It embeds Llama, CPP for local inference, not a public model server. Communication stays private. GGUF is planned local model data for Llama. CPP, not permission or a security boundary. Quantization lowers precision to save memory and may reduce quality, so each candidate must be measured. Vulkan is the planned cross-vendor GPU interface. Current NVIDIA CUDA verification does not validate it. The target is Linux x86-64, a discrete Vulkan GPU, at least 8 GB dedicated VRAM, full offload, and 8,192 context tokens. VRAM is graphics card memory. Unmet target stop startup, no CPU fallback or context shrink. The transport choice is open. No worker or target runtime proof exists. A local AI release needs more than model bytes. Pinned source and tools should produce matching payload bytes in independent clean builds before a build is called reproducible. A manifest lists expected files, sizes, and identities. SHA-256 is their digital fingerprint. Changed or incomplete bytes can be rejected. Full values stay in the evidence. A software bill of materials, or SBOM, is the release's ingredient list. Provenance is the traceable chain showing which sources, tools, and process produce the artifact. A detached signature shows exact metadata came unchanged from the expected publisher. It authenticates metadata, but grants no permission and proves no model output correct. The target OS verifies metadata, rejects unsafe paths, checks the staged payload, then activates it. Signing keys and trusted policy stay outside the bundle. Today's adapter revision and SHA-256 hash are verified, but they are not a native release chain. No signed bundle, production SBOM, activation, or OS verification exists. This signed-out GitHub page is the real Codegeist LLM mirror. Its README describes a compact local inference component for Codegeist OS with authority outside the model. Architecture, evaluation, security, and the task file document strict public adapter verification. They describe the design. They do not prove a worker or OS integration exists. The public task file makes verification inspectable and repeatable, but it does not prove a working OS integration. This signed-out Hugging Face repository contains version 0.2.1, the first adapter, model card, sanitized evidence, and checksums. The adapter is a small add-on loaded with an existing base model, immutable base and adapter revisions, plus a recorded SHA-256 fingerprint, bind shortened identifiers to complete evidence values. This narrow milestone proves neither production readiness, coding, safety, nor generalization. Next, a real NVIDIA GPU verifies one anonymous public load. This is real evidence. Source, base, and adapter revisions and fingerprint are fixed. The raw recording and event timeline are retained. We start task infer at real speed. It prepares the locked inference environment and verifies the public artifact. No environment dump or credential appears. The verifier loads QN3-1, 7B as the base model and the Codegeist adapter from immutable revisions. The fingerprint must match. Implicit hub token use is disabled, remote model code is disabled, and no token goes to either public loader, making this an anonymous reload. Setup can take time. Command start, verification gates, and results stay at real speed. Only the measured middle weight is shortened, with its factor calculated from retained raw and rendered durations. During this accelerated interval, the verifier retrieves and loads the fixed public artifacts, then checks the pinned adapter fingerprint before inference. The edit remains tied to the complete raw run. Acceleration shortens waiting, but changes neither the command nor the recorded evidence. CUDA is NVIDIA GPU platform. Every parameter and buffer must be on CUDA. CPU fallback fails. Every floating parameter must use BF16. That describes loaded state, not quality. These checks describe placement and numerical format only. They do not measure model quality. The approved response appears, and the verifier reports an exact match. One anonymous reload verifies the fixed hash, CUDA-only BF16, and one exact response, not Vulkan, Codegeist OS, coding quality, safety, or production readiness. Real proof is useful only when its boundary is clear. So here is the current state in 2 columns, verified today and not yet proven. Verified today means public source and adapter, immutable identities and SHA-256, anonymous loading, every parameter and buffer on CUDA, floating parameters in BF16, no CPU fallback, and the exact response shown. Not yet proven includes coding, reasoning, generalization, safe tools, prompt injection resistance, and production quality. Future integration also remains unproven. Codegeist OS, the native worker, GGUF, Vulkan, 8192 token behavior, 8GB compatibility, signing, and a validated sandbox. One public response proves one reviewed identity and verification path, not intelligence, broad capability, safety, or readiness. Future claims require representative workloads, held-out evaluation, hardware and security tests, and reproducible release evidence. Roadmap means ordered evidence gates, not a calendar or release promise. Each gate permits another test, not readiness. First, define representative read-only workloads and canonical Codegeist OS schemas for observations, proposals, failures, and cancellation. Measure the unchanged model before adaptation. Change it only for a demonstrated, correctable deficit, then compare behavior across every transformation. Create project-controlled GGUF through pinned conversion tools, evaluate quantization variance, and preserve source, writes, integrity, and provenance. The Vulkan spike must prove full model and inference state offload. Worst case 8192 token behavior, memory limits, and fail-close startup on target hardware. The native worker then needs a bounded private protocol, constrained output, defense in depth, and independent authoritative Codegeist OS validation. Evaluate diagnosis, abstention, prompt injection, failure, cancellation, and recovery. Invalid results must never reach tools or policy. No usable Codegeist OS release exists. Release still requires reproducible evidence, signatures, and a tested sandbox. Visit Codegeist on GitHub. Explore the open-source projects. Contributors are welcome. The model may advise, the operating system must decide.